Yes, what is the answer? 2. 2 meter per second square. Let us check then. Look, this says that a car is moving with a velocity of 10 meter per second and takes a U-turn. See, you have just divided 10 by 5, right? 5 seconds is the time given. Here, when U-turn is given, we have to consider the sign convention also. See, this is the starting point, initial point. The car is moving, velocity is 10 meter per second. It takes a U-turn, right? And comes back. This is the final position. Now also the velocity is 10 meter per second. How do we know this? Because it is written with the same speed. So this was the speed. Now it would be 10 meter per second. Now class, use a sign convention. Sign convention says that you can take any of these direction, right or left, as positive or negative. Take any of these as positive and any of these as negative. Suppose I've taken right as positive. So this is pointing towards the right. This is pointing towards the left. This will be positive. This will be negative. I can choose the opposite one also. I can make this negative. I can make this positive. See, sign convention totally depends upon you. It's just that in your final answer, a positive and a negative sign will determine whatever you've chosen earlier. Like I have chosen left as negative. So if my final answer comes negative, I will say direction is final answers, accelerations, direction is towards the left. So see here, what have we studied about acceleration? This is the change in velocity by change in time. Final velocity minus initial velocity divided by final time minus initial time. Our final velocity is this when it is turning after taking a U-turn, and initial velocity is I. So minus 10 minus initial velocity is 10 divided by time is given as 5 seconds, right? So 5 minus 0. So this becomes minus 20 by 5. So this is equal to minus 4 meter per second square. Now magnitude, our magnitude, this 4 is the magnitude. Magnitude means without the sign, just a number. What is meter per second square? It is the unit. And what is this negative sign telling? Negative sign telling left. The final direction of acceleration is towards left. Ali, is it clear? Yes, Ali. All right, start writing this. See, class, these are the equations of motions, uniformly accelerated motions, which we have to use. Now, understand one thing. Uniformly accelerated means our acceleration is uniform, as in the value of acceleration shouldn't change. There is a certain value of acceleration that will remain fixed. You cannot have, you have to have a uniformly acceleration fixed, whether it's zero, then only these equations are valid. So uniform acceleration motion equations where acceleration has to be uniform. So three equations we have, class. V is what? Now understand the variables first, the equations. V stands for the final velocity of the body. And see, so as to differentiate the initial velocity and the final velocity, we have the symbol U for the initial velocity. So final velocity means the velocity with which the body stops. Initial velocity means the velocity with which the body begins its motion. Now, A is the time instant, time instant, and this is valid for the time duration as well. S acts as our displacement of the body, and if we are talking in scalar terms, it becomes our distance of the body. These variables are different. We do not use D for distance, F for final velocity. So these symbols are fixed, class. All right, because in every book you will be encountering these variables only. Now on the Is it better? Alina, just update me in the chat column. Now is it better? I've changed my internet. Is it better now? Please update in the chat column. Okay, okay, thank you. See, I was saying you have these symbols which are fixed, and in every book you will be encountering these symbols only. This is not like your sign convention where you will be deciding which thing to choose, right? V is the final velocity of the body. U is the initial velocity of the body. A is the acceleration of the body. T is the time instant or time duration. Both can be valid. And S is the displacement of the body. Now let us come to our uniformly accelerated equations. V is equal to U plus AT. S is equal to UT plus half AT square. V square minus U square is equal to 2AS. Fine, V square minus U square is equal to 2AS. These three equations we use means final velocity is equal to sum of initial velocity and product of acceleration and time. Second equation means displacement is equal to the initial product of initial velocity and time with added to half of product of square of time and acceleration. And last equation we have square of final velocity minus square of initial velocity is equal to 2 times the product of acceleration and displacement. So V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. You have to remember these equations, class. These equations, without these equations, you'll not be able to solve any question, not just for this chapter, for projectile motion, for the upcoming chapters, even in your class 12, you require the knowledge of these three equations, these three equations. Rather, we have 4 equations. The fourth one I'll tell you later. First, write down these. See, this says that a body starts with a velocity of 2 meter per second. So if it is starting with a velocity of 2 meter per second, it is the initial velocity. Acceleration is already mentioned as 2 meter per second square. Now we have to calculate the velocity after 2 seconds. So amongst these three equations, the first one is valid because we do not have distance. So we should avoid using the second and the third equation. The first one is sufficient, V, U, A, and T. So if I use V is equal to U plus AT, U is 2 plus acceleration is 2, time is 2. So this becomes 2 plus 4, which is equal to 6 meter per second. This is the final velocity which is required. Now displacement covered in 2 seconds. What is the displacement covered in 2 seconds? Let us use ut plus half at square. Now see what is the initial velocity? It is 2. Time is also 2 seconds plus half into. Acceleration is given as 2. And time is also given as 2 into 2. So this becomes 4 plus 4, which is equal to 8 meters, right? And then we have the last part. Velocity of the after the body has covered a displacement of 2 meters. Now this is given, distance is given. This is the third part. This was the first part. This was the second part. So V square minus U square is equal to 2AS. V square we have calculated. V square we have to calculate this in this question. Minus U square, this is 4. 2 into acceleration is 2 into distance is given as 2. So V square minus 4 is equal to 8. V square is equal to, this is 8. 8 minus 4 is 4. V is equal to 2 meter per second. Write down, class. See, this says that a body starts with a velocity of 4 meter per second and accelerates at 6 meter per second square. Same question, class, just the values have changed. I want answers from you. See, it's similar to the previous part. Class answer, I'm giving you 3 more minutes, okay? Exactly at 50 I'll ask. Please share your answers. Yes, class. I think 3 minutes was sufficient. Okay, Alina has responded. Ali, you should also have responded at least in this question. So this was just a direct copy paste question with just a change in some values. See, here we have the initial velocity as 4 meter per second and acceleration is 6 meter per second square. Velocity of the body and time is 5 seconds. So see, for the first part, okay, Alina, good. V is equal to U plus 80. V is U is 4, A is 6, T is 5, V is 4 plus 30. Very good, Alina. This is 34 meter per second. Okay, Ali, very good. Very good. Second part says displacement covered in 5 seconds. S is equal to UT plus half 80 squared. U is 6, time is 5, I think. Yeah. U is 4, time is 5. U is 4, time is 5 plus half into 6 into 5 into 5. So this becomes 3. 3 into 25, 75. 75 plus 20, it's 95 meters. Correct? Last part. When the displacement is 10 meters. Displacement is 10 meters. So V square minus U square is 4 square is equal to 2AS. V square minus 16 is equal to 60 into 2. This is 120. So this becomes 120 plus 16. Right? So this is 136. So this is 136. No, 6 here we have. And here we are having 16. Right. So when we'll be calculating this under root 136, 13 and 12 is 121. How much it would be? 14 is 196, 136 V square. Not 1156. It would be root. This is root 136. It would be around 11 is 121. So 11 point something. I think earlier it was 11.6. Yes. So it would be around 11.6. 11.6 meter per second. Write down class. Okay, class. So I was informed that today's class was of 1 hour. So the class ends here. So I'll meet you all in the next week now. All right, tomorrow is an off. Thank you so much, class. You can leave.
Thank you, ma'am.